of story problems is drawing the picture correctly. Right, the right spot on the right spot. So it's easier when they get the picture because it's draws the triangle. I will tell you that in these story problems, we're going to go back to degrees because outside of math class, people use degrees. In math, degrees don't work in calculus. They just don't work when you're just calculating math degree measure, so that's not precalculus. But angle of elevation is the angle through which the eye moves up from the horizontal to something above. So like if I was standing here and I was looking up at the top of a tree, the angle of elevation would be what angle am I looking up to the top of that tree. So usually we just measure that from the ground. Technically, if we were talking about me looking up, we should be measuring it from my line of sight, but usually we just say from the ground. But that would be like if I'm on the ground looking up at something above, then this would be your angle of elevation. And then you can make a right triangle. The angle of depression is not how you feel about this class, but it is, I just wait till someone laughs. But it is the angle through which the eye moves down from the horizontal to something below. So if I was standing on top of a building looking down, then the angle that I was looking down is the angle of depression. But it's from like this imaginary horizontal line. So if I was like on top of a building, and I was looking down, again, we're going to pretend that it's just top of the building. Right? It's not this angle here, which is a mistake that people make. It's the angle, if you imagine like drawing a horizontal line out, it's this angle right here. We can talk about angle of depression if you use what you learned in geometry class, and you think about what the angle down here would be. Right? Is this angle going to have the same measure as this angle down here? Because they're alternate interior angles. And so if you know the angle of depression, you can always just mark it down here as well. And we'll do that in this example. But to me, those are the biggest vocab words that you need to know as you do story problems, because that's the hardest part, is where do I put my angle? Usually they talk about vertical height or height of a tree. How far away are you standing from it? And so those values are easier to find. It's the angles that we okay. Alright, so here's one of my radio towers. An amateur radio operator builds a 75-foot tower for an antenna. Find the angle of elevation to the top of the tower at a point on level ground 50 feet from the base. So, you just want to label things correctly, and I think easier than some of the stuff that we've been doing in this chapter is this just kind of goes back to SOHCAHTOA, right? Like you just look at the picture and you say, which trig function do I use to set up this problem to solve? But again, it's about making the picture right. So the tower, 75 feet, so this is my lovely radio tower here. And the angle of elevation to the top on a point on level ground 50 feet from the base. So 50 feet from the base. And I want to find the angle of elevation from the ground up to here. So that means I'm looking for that angle. Again, draw the picture as you're doing these. Some of the ones in your homework give you a picture, some of them don't. So definitely don't give you a picture, draw that. Because then it just goes back to, this is the opposite side, this is the adjacent side, so I could use tangent here and say the tangent of theta equals 75 over 50. And then what am I going to punch in my calculator if I'm trying to find an angle? How about you, calculator? How do you use calculator? Hold on. What do we type in our calculator if we're solving for the angle? The inverse, right? So we're not getting tangent. We're getting inverse tangent. And again, in story problems, using degrees makes more sense than using radians. So I'm going to be in degree mode, and I'm going to hit inverse tangent of 75 over 50. And it doesn't really say what's round to. I'm just going to go to 1 decimal here, and I got an answer of 56.3 degrees. I think that step 1 I would say is check your The angle of depression from the top of the Smoketown Lighthouse, 120 feet above the surface of the water, to a buoy is 10 degrees. How far is the buoy from the lighthouse? Again, it's just all about making sure you do it correctly if you're looking for the right angle. The lighthouse is 120 feet. There's a buoy out here. I want to know how far away this is. Right? I'm going to call that X. But they give me the angle of depression. And again, that would be like if you measured straight out from here, the angle looking down, this would be 10 degrees. So you can either use this triangle, right? Like you can make this distance, you can measure it like this. That's the right angle. This is going to be the same height as your lighthouse. And this could be your X, right? That will always work. But what a lot of people tend to do is they use those alternate interior angles, so these would be 2 parallel lines with the transversal cutting through. That if this is 10 degrees, it's also going to be 10 degrees. So if you know that, you could just label this as degrees down here and not have to fill out that. We just did stuff like this in my geometry class, which I just learned so and they had a self-story problem. And someone asked me, in story problems, is it always tangent? Because it seems like we use tangent a lot. And the answer is no, it's not always tangent, but it tends to be that you know the opposite and the adjacent side, or you're looking for one or the other way more than the hypotenuse. But it seems like a good guess would be to always use tangent, things like that. On this one, right, if you set that up, you're going to get tangent of 10 degrees equals 120 over x. So if I know the angle, I don't use inverse. And then I just have to do the algebra, right? So if you multiply by x, right, and then you divide the tangent over, I always know if I'm looking for the denominator, then that means I'm going to take 120 divided by my trig function. So just be careful with your algebra there. It was pretty far. I got, again, don't say what's that, 680.6. Did this in geometry, you did do all this other things with the inverse and the graphing, but you know, so then the only other thing we can maybe do is make it a little more complicated, and it says an observer in a lighthouse 350 feet above sea level observes 2 ships directly offshore. Those are the fancy ships I put there for you. The angles of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? So you have to do a little bit more work in this one, because we're trying to find this distance, but we can't find that distance. What we can find is the distance each of them are to the lighthouse, and then we can take that on here. So if you need to make 2 pictures out, you can. This, right, and then measure up here. Colors here, then I can find all the way here, pull that resistance off, and I can move it. It kind of doesn't matter which way you put the trace in, because if you know what you're going to do, you're going to be okay. But if you think about that angle of depression, which one of those should get the smaller angle of depression, the closer ship or the further ship? The closer ship should get the smaller degree. The further away should get the smaller degree. I always just kind of draw it. So like if I drew this one, that would just be that amount, right? And if I did the red one, that would be from the horizontal down to here. So the closer one has the bigger angle of depression there. Again, if you labeled them wrong and you solved it correctly, you're still going to subtract the bigger one from the smaller one when you get to the end, so it's going to work out the same way. But I just kind of let you think about that. This, and I'm going to label it down here if you're okay with that. This would be the 6.5 degrees. And then the blue one would be the 4 degrees. Sometimes that gets a little messy, so if you kind of label that, and then you want to come off to the side and draw two triangles, one with the 6.5 degrees, one with 4 degrees, kind of makes things a little bit easier, especially when you don't have different colors. This one's a lot taller lighthouse, right? This one's 350 feet. And again, we're going to use tangent, so if you kind of start setting that up and solving it, see if you can do that and get this value good. Did a question just like this is geometry book, except for two dolphins off a ship. So again, when you're looking for x on the bottom, right, you're going to take 350 to the side and draw a tangent of those equals. Well, that's what x is, direction of y. You can definitely see that on the calculator part of our test, the calculator is kind of a really important part. So again, if you have questions about using the calculator, you want to make sure you talk about that before taking the test. So I got that the further ship away was 5,000-ish feet, and the closer ship is 3,000 feet. So then we just subtract them to find the distance between them. I took 350 divided by tangent of 4, because if I multiply y over here, oh, there you go. So the distance between the ships would be 1,933.3. These are kind of silly questions, but you can definitely see how right triangle trig could be used outside of math class. Sometimes the stuff that I teach right here, you know, like graphing speaking, when you're going to use that outside of the class, but right triangle trig, I feel like that's part of why geometry has always been in classes every day, because learning that is something like useful. So, what did I have on here? So this is homework 4-8, and I just picked a few questions. That's a lot of time of work, so you should not like that question. And then we're not having our test until Tuesday, right? I want to have a little quiz tomorrow, just to kind of see where we are on 4-7. So it's a one sheet of paper. Most of it is going to be from 4-7, meaning finding values from your unit circle or doing inverse trig from your unit circle where you have to know the restricted domains and ranges. I think that 14 of the 20 points is that, which means you have to know your unit circle, and you have to know the inverse trig. You have to know that sine and cosine, sine and tangent are negative pi halves to pi halves, and that cosine is 0 to pi. And then there are going to be two graphs, crazy graphs. Okay, we have a test coming up. I want to kind of see where we are on the graphs. Look over your trig functions and remind yourself how to graph those. That packet I gave you back that was 20 points, that packet would be a good thing to look over and just say, hey, if I have a sine or a cosine, do I know how to graph those? Where are my asymptotes, right? Tangent and secant have the same asymptotes. Cotangent and cosecant have the same way that you find the asymptotes. So that would be 3 points each on those. So 3 points for each graph. So that's 6 points of graphs, 14 points of knowing your unit circle and your inverse trig. So very similar to the homework that you had on 4-7 days. Okay? Questions about that? We're going to do that tomorrow. That'll be first thing. And then when you're done with that, I'm going to give you your chapter review to work on. The quiz shouldn't take you very long because it's just, 14, 15, 16 questions. 14, like, for the most part. Review. And on Monday, we'll go over what questions you're going to ask, the graphs, and then we'll take that. Excited, Tyler? I can tell by your head on your